Welcome back to the Lowdown on Physics. This is the 8th and final screencast for the Area of Study Interactions and Light of Matter. VCE Physics, Area of Study 2, which we're doing first. So we'll wrap it all up, tie it all together and come to the conclusion that light just doesn't make sense. Okay, so going back to the last screencast, we had Bohr's model of the atom, which accounted for a stack of observations that were made about the absorption and emission spectra. But the question is, did it actually account for the actual energies of the hydrogen spectra? Or even more so, did it account for spectra of other elements? So, whilst Bohr did some amazing things, there were a few issues with the model. So basically, his analysis was of hydrogen, but we couldn't use this to help explain what was going on in other atoms. So along came de Broglie, and he used this idea. He linked matter waves. They're back again. Sorry about that. And he used this to explain why electrons in orbits have these quantized energies. What do we mean by quantized energies? It's these energies of exact values between these orbits. So de Broglie used this idea of standing waves, and basically what he said is if we can think of particles as matter waves, then they need to be in a stable energy value. If they can't maintain stable energy values, then they can't exist there. They can't be there. So what he did was he viewed the electrons in orbit as if they're orbiting in a wave sort of pattern, and he suggested that only an electron could maintain the only way that the electron could maintain a steady energy level, or that is a stable orbit, is if it established what we call a standing wave. If we want to think of a standing wave, it's a sort of a three-dimensional wave, or this wave pattern going around cyclically. If you want to think of a standing wave is like a guitar string being plucked, and then basically if you then wrap that guitar string into a loop, then you create that three-dimensional sort of standing wave that this electron would be travelling along as it moves around the orbit. So let's try and put an image to that to help concrete what's going on. So basically he said the electron can exist if it fits perfectly into that orbit. Okay, that's the only place that they could exist, is if they have a perfect wave, so it goes around cyclically. If it doesn't, so if we've got multiple wavelengths or a number of wavelengths, but they don't fit into an orbit, that is, it doesn't finish where it started, then it can't exist. So here it sort of always finishes and starts at the same point, so it perfectly meets up. Whereas around here, it doesn't meet up and start at the same place. So this standing wave cannot exist. So this is really the key concept that you've got to grab here. I've seen a couple of questions on this, and really it's kind of an explanation. You can kind of come up with a 2D drawing, I'll show you that in a sec, to help explain it. But basically, if it doesn't fit into a whole number of waves, it can't exist. And so there's only going to be a series of quantized values in which it will be able to fit those whole waves together. So here we've kind of got like it's vibrating and creating two whole waves. Here it's vibrating, it's creating 1, 2, 3, 4 whole waves as it goes round. Okay, here we've got 9, here we've got one where it doesn't exist, it doesn't work because we don't start and finish at the same point. So that's a useful drawing. I just pointed at the screen. That's not very helpful to you, is it? This can be a really useful drawing if you have to do an explanation. What about if we wanted to calculate? So firstly, it's going to be a whole orbit. The circumference of the orbit has to match a certain number of wavelengths. So for 3 wavelengths, it would be 3 pi has to equal 2 pi r, where r is the radius of the orbit. But if we want to come back to our standing waves and think about matter waves, sorry, then we've got lambda is also equivalent to h divided by mv. We could substitute that in place. So now we get this equation, number of waves times h over the mass of the electron times its velocity must equal 2 pi r. So we could work out the radii of the orbit, or if we know the radii, you can work out the velocity or the number of waves perhaps, depending on what the question had. I'd whack that on my cheat sheet just in case, just because it's a nice, simple, easy formula to substitute into. So that's it. We are so close to finishing. The only really thing to say there is that what this did was provide theoretical relationship to what Bohr had assumed existed when he came up with his theory. So we now had theoretical substance to his idea. So, in conclusion, what is light? Really, it's been a consistent story the whole time. We're getting light displaying wave behavior, particle behavior, as do the electrons and other forms of matter, particularly those small ones where we can see that wave model thing. So the two models are actually a complementary way to describe what light is or how it behaves and what it does. So we observe behavior that is consistent with wave properties, or we observe properties that are consistent with particle properties, but we never seem to observe the two simultaneously. So that's it, really. We have just finished off area of study number 2, which we did first. Really, the key thing that you're going to have to remember is whether proof showing that it's behaving as a wave, that's diffraction. Proof showing that it's behaving as a particle, that's looking at the photoelectric effect. And then the other key thing is going to be Bohr's model and how we have explained that using this idea of matter waves in the orbits around the atom. All right, good luck. So now it is just tying it up. Let's do some revision, and I'll see you in class shortly.